double check in with you to see if anybody, let me pop in and see if I can unmute you. I'll stop the share for a second. I just want to make sure, does anybody have any questions so far? If so, pop up or see something in the chat.
Yeah, I do. These slides going to be on Google Classroom for us to view?
Yeah, thanks, Alexia. Yeah, Timur, there is posted in Google Classroom. I'll double check it after this lesson. I'm pretty sure I put it up already. You have the Google Slides and the quiz. The quiz shouldn't take too long. Again, though, make sure you get 100%. Go ahead and look in your Google Class. Go ahead, look in your Google Classroom for the quiz. Next to it, and the same thing is that slideshow presentation, and look at the slideshow to get the answers to the quiz if you need it. If you're unsure, go back to the Google slideshow. It's there. Everything's there for you. There's no reason you shouldn't get less than 100%. And here right now, we're going to quickly talk about I got to pop up the thing that I'm going to give you. Here's the extra quiz question that you need to know. It's not popping up. It's called demosaicing. So if you have your phone, or if you have type on your computer somewhere, or write on a piece of paper, demosaicing. I'll explain it in a second. I want you to write this word down. It's demosaicing. 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 Okay, did I spell that right? Mosaic. mosiacing. Demosaicing. Okay, write that down. What demosaicing is?
Wait, how do you spell that again?
DEMO.
Okay.
SAICING.
So like this?
Yeah, demosaicing like that. Okay.
I thought it would be a K instead of a C.
The middle word is mosaic. Mosaic you should see in your art classes or history classes. People still do it today, but they used to do it a lot with floors in ancient times, or walls, where they take little squares, kind of like often you might have in a bathroom shower or tub. You have a bunch of tiles that are next to each other, just little squares or rectangles, and they're of different colors. And those different colors, when you stand back, it creates a big picture. It's called a mosaic. That's kind of similar to what's going on when you're creating an image with pixels we talk about on our computer graphics class, or in these pictures right now that we take on our cameras. It's just a bunch of little points, little tiny squares that are next to each other, creating a mosaic. Now, demosaicing, what that term actually means is when one of these image sensors is picking up an image, what can happen is in order to try to get a really good image, they'll use 2 green filters and then 1 red and 1 blue filter. And the purpose of that is because our eyes like the color green, apparently. But what it's doing is, it's because you have 2 green filters, it's not actually, it has to interpret what the color actually is coming from the outside to make a guess at the other colors, the red and the blue, what they're actually going to be like in order to create a perfect, clear picture. So it's called demosaicing, and that's the last question on the test that's not in the slideshow. Since you wrote down the word, once you get to that question, just look for the word demosaicing, and you've answered it, and you've gotten that question answered correctly. So let's jump back into the slideshow. For some reason, it popped away to the end. Excuse me. Okay. So we just went over the image sensors. Now we're moving on to lenses. This is vocabulary for lenses that you'll need to know for the video that's about to play next. It's going to move fast, so I want to slow down here just to make sure that you understand the vocabulary you are going to hear. Lens is pretty obvious. Most of us know it because of eyeglasses. We have lenses, which is a piece of glass which with curved sides, it bends light, puts things into focus for us. There are several different types of lenses. The main two ideas we want to, or words that we're associating with lenses that we need to know are convex and concave, which is on the next page. A convex lens is a surface that is curved like the exterior of a circle or a sphere. So it's bulging outward. A convex lens is bulging outward. A focal point is the point at which rays or waves meet after refraction. We'll talk about refraction in a second. But what happens is when light comes through a curved convex lens, let's say, or any lens, but when it comes through a curved convex lens, it's coming in and then it bends in a different direction. And all of these, and that bending is called refraction, a change in direction, in this case of light, when passing through a medium. So it bends those light waves, and those waves will converge, which means they meet at a single point. Two people can be doing this. They converge. Converge as a vocabulary word. Two people are walking, they get closer and closer, they converge together. So the focal point is that point at which the rays or waves meet after refraction. Spherical aberration down on the bottom right. An aberration is it's an error or kind of an anomaly error. And that's kind of what it means. A spherical aberration is a loss of a clear image, definition from a spherical round lens. And the reason why that happens is because if you can imagine, well, I'll pop to the next page. Why is it doing that? If you take a look at that convex lens on the right, once light passes through the convex lens and it comes out the other side, light from the top and from the bottom have a longer distance to travel than light that's coming through the middle. And that's what causes a spherical aberration, you will see in the video. A chromatic aberration is also caused by that light passing through the lens, but it has to color, it deals with color. Chromatic is color. And what happens is color has different light wave lengths. So a red wave is longer than a green wave, which is longer than a blue wave. And it creates this chromatic aberration, which is kind of a, fringes are, it says failure to focus causing colored fringes. Fringes are like at the end of a piece of material that is frayed, kind of. Fringes are just kind of like little fingers that stick out, but it just looks blurry essentially. As I said, there's a convex lens, which is on the left. If you look on the right side of the screen, it's the left bulging out lens. And a concave lens, it curves inward. So it's a surface that is curved inward like the interior of a circle or a sphere. And distortion is obviously just things pulled or twisted out of shape. So those are all the vocabulary words you need. You could come back here if you need to, if you're confused about anything that's said in the video, you can take a look at it, but here's the video.
If you look at a scene through a single lens, it appears upside down. Why is that? Lenses that are thicker at the middle are called convex lenses. These lenses cause parallel light rays to converge to a single point, called the focal point. When light rays pass through the lens, they do not travel in straight lines, but rather bend slightly inward. This phenomenon is called refraction. When light rays pass through the lens, they refract and converge to a single point to produce an image. Because the image passes through the lens to the opposite side, it is projected upside down. This process alone, however, is not enough to produce a sharp image. This is because, strictly speaking, a spherical convex lens alone cannot cause light to converge to a single point. The focal point where light rays passing through the center of the lens converge differs slightly from the focal point where light rays passing through the edge of the lens converge. This is called spherical aberration. In addition, color fringing may occur. This is called chromatic aberration. When light passes through a convex lens, the focal point for red light, which has a long wavelength, is farther away from the lens than the focal point for blue light, which has a short wavelength. This causes colors to shift. As a result, colors appear to bleed. Making light converge neatly to a single point requires technology. Since the direction in which spherical aberration occurs in a convex lens is opposite to a concave lens, through a combination of two or more lenses, light rays can be made to converge to a single point. This is called aberration correction. Chromatic aberration can also be corrected by combining two lenses. To achieve the most beautiful images possible, actual camera lenses incorporate multiple individual lenses that correct focus and color bleeding. Lenses for single-lens reference cameras are made up of a large number of lenses. Each lens is responsible for such roles as adjusting colors, distortion, and focus, as well as changing the focal distance. Canon takes pride in its diverse lens lineup. Each model features technology designed to capture beautiful images.
Okay, does anybody have any questions about that?
That sounded more like science and less of broadcasting, not gonna lie.
Any questions? Okay. So I went ahead and muted everybody for the rest of this, and I'll unmute at the end. So one thing that you should know, it's not on the test, but cameras such as, I think the only real cameras these days that may have them, if they still have disposable cameras, they have a fixed lens, which means there's a lens in place. You can't move it. It's just going to wide open, say, okay, I'm going to take a picture of everything. Same thing with Polaroid cameras. I think they still have Polaroid cameras. But these DSLR cameras or broadcast cameras, you have the zoom and the focus rings, and those things actually move those lenses back and forth and closer and farther away from each other. It's a complex system that I don't know a whole lot about. I just know it exists. So know that about cameras. Other than that, as I said, all the answers to the quiz are in the PowerPoint, which is online. I gave you the one answer that's not in the PowerPoint. You should have written it down, demosaicing. And unless anybody has any questions, just remember that I would like you to finish this quiz. You have 40 minutes right now before the end of class. I'm sorry, 20 minutes right now before the end of class. But just have it done before our next class on Wednesday. And please try to see if you can download and install Adobe, just so I can make sure that that is working out. You can email me at any time if you have any issues. And you could send messages on Google Classroom. So I'll give one last chance to let anybody know, have anybody ask me questions. Does anybody have any questions? No? All right, everybody, thanks for coming. I'll put this recording online as soon as it's ready. And have a great rest of your day, and I'll see you on Wednesday. Bye now.
Okay.
All right.